All right, now it's time for notes over lines of fit. We have three different types of lines that we're covering. Uh, we have linear, and we know it's linear because the general line follows a linear path. We know this one is quadratic. It is nice and slopey and growing. And then this one's more exponential. Exponential grows a little bit faster. So exponential, or it decays really, really fast. So things usually happen quicker with exponential than quadratic. All right. The first things first, you need to turn on what's called diagnostic. Now, before we do that, while we do that, we're going to do that together. Turn on diagnostic. What this is going to give us is it's going to give us an additional number whenever we do stat, and that additional number is going to tell us how sure is the calculator to its answer, right? Like how good is the answer, in other words, okay? So let's turn on stat together, and then I'm also going to show you what it looks like without stat, or without diagnostic. So let's turn on diagnostic together. First, you're going to hit second, and then you're going to hit zero. So second, and then you're going to hit zero right there. And it brings up this catalog list. You're going to scroll all the way down, or you can use the letters. Do you see the green letters on top of your calculator? You're going to scroll all the way down to D, and you're going to find diagnostic on. You have diagnostic on, diagnostic off. And then once you find that, you're going to hit the enter button 2 times. So once and then twice. Do you see how it says done? Right? Diagnostic on, done. All right. Now this calculator doesn't have the diagnostic on. Okay? I will show you the difference. So let's plug in some numbers. I know that I already have some stat in here, and I think it's quadratic. So I will do that information. Let's see. Let's make something up. I'd rather make something up. Delete. That's what it is. All right. And we're just going to make up some data. And let's see this one. Stat, edit. Delete. And that. Okay. We're going to put in the same data. I'm going to say 1, 2, 3, 4. And then I'm going to make up some numbers. And it's going to be the same for each, just so you can see what the diagnostic does. So let's say 2, and then 5, and then 6, and then 8. Okay, we have the same numbers here. 2, 5, 6, and 8 for our y's. 1, 2, 3, and 4 for our x's. I'm going to do a linear thing, even though I know that it's not exactly linear. This is for when you have a couple of bumps in your data, right? So it's not perfectly linear. You can see the difference between here and here is 3, then 1, then 2. Okay, so let's go back to stat. Let's go over to calc. We're going to go down to linear regression, okay, for both of these at the same time, and I'll be able to show you what the difference between the two. Remember, this has diagnostic on. Let me see if I can turn off this light here. Does that? Okay. This has diagnostic on, and this does not. So here's the big difference. Do you see the difference? We have 2 new features, r squared and r. Well, when we have linear data, r squared is trash. We don't count it. R is what we're looking for. Do you see how it says 0.98? Okay, well, we got the same answer for A, 1.9. We got the same answer for B, 0.5. But that R value, that's what we're looking for today. That's the meat and potatoes of today's lesson. That number tells us how sure the calculator is that this is the right equation for this data that we input. Okay? Because if we plug in this info, right? Let's look back at stat real quick. If we plug in this info, if we plug in that equation that we learned right here, 1.9 times x plus 0.5, let's do that in y equals 1.9 x plus 0.5. When we plug that into the calculator, we should be able to go to a table and get that data, and we didn't, right? I put 1 and 2. It says 2.4. I put 2 and 5. It says 4.3. I said 3 and 6, and it says 6.2. I said 4 and 8, and this is 8.1. Okay? So it's not exact, but the calculator says, it's pretty dang close. Okay, here's what that means. That's a 98% sure chance, right? So if we had to change this decimal to a percent, we'd move it over, call that a 98% accuracy rating. All right? So here's what that is. That's our correlation coefficient. And it ranges from -1 all the way to +1. If that R value was a 1, it would be exact. Or if that R value were a -1, it would be as exact. Okay? Whenever it lands on -1 or +1, the calculator is 100% sure that that is the right answer. Now, the closer it is to -1, if it's negative, or the closer it is to +1, if it's positive, the stronger the correlation coefficient is, right? The more sure the calculator is, right? So this number, this R value, is very close to 1. It's 0.98, right? It's very close. It's less than 0.02 away from 1. That's very, very close to 1. So the calculator is pretty dang sure that's gonna give you a good estimate for the future. So if I plug that like I plugged in that equation in here, if I want to guess what happens on year 15, the calculator's pretty sure. Excuse me. If I guess on year 15, the calculator's pretty sure that 29 is going to be very, very close to the right answer. Okay? So that R value, whenever we're linear, is what we're looking for. As soon as we do quadratic and exponential, we're talking R squared. All right. Either way, this is what we're looking for. We need it close to -1 or exactly -1 or close to +1 or exactly +1. The closer it is to 0, the weaker it is. Meaning, if it's closer to 0, if this was 0.2, then the equation that went along with this, the calculator's like, maybe. Maybe it's right. It could be way wrong, though. So the diagnostic turns on that correlation coefficient that tells us how sure the calculator is that our data is accurate. Okay? I'm going to turn off or pause real quick and go get some water. All right. So number 1 is talking about canceled check fees and years since 2013. It says, what's the linear line of best fit? So it tells us it's linear. So what we're going to do with our calculator that has the correlation coefficient turned on, we're going to go back here and we're going to plug this information into stat. So, all right, we're going to put in 0, 1, 2, and 3, just like it says on the table. Then we're going to put in 5, 10, 10, and 15, just like it says on the table. We're going to go over to stat, over to calc, and then down to linear regression. Now, why are we doing this? Because it is telling us our equation. And it says it's going to be pretty close, 0.94, right? So it's pretty good. What is the linear equation that it gives us? It gives us y is equal to 3x plus 5.5, right? That's our A, that's our B. Y is equal to 3x plus 5.5. What is the correlation coefficient? 0.9. Let's estimate 0.95. It's super close, okay? And then now we're going to estimate to year 15. So we're going to go over to y equals. We're going to plug in that equation, 3x plus 5.5. And then we're going to go over to our table and go down to year 15. And our best estimate is 50.5. And we're talking about dollars, so $50.50. Okay? That's exactly what it's doing. And we're pretty sure that's how much it's going to cost in 15 years. Not exactly sure. All right. The next one says new information. So edit, and we're going to delete. Actually, we're going to keep that information. Oops. 0, 1, 2, 3, 4, 5, and 6. Go over here. You remember you can type on top of numbers. 55, 70, 83, 76. Do you see how the numbers are jumping around everywhere? 92 and 90. Now, it says, for the next one, it says, what is the quadratic line of best fit for the data in the table? This is our study. This is our exam score. All right, so what's the quadratic line? It's already telling us quadratic regression is what we need to use. So stat over down to quadrag, enter a bunch of times, then it gives us the equation. Yikes, right? It's ugly. So negative 1 point, let's call it 0.6x squared plus 11.82x plus 57.31. Okay, that's kind of our messy equation. Negative 1.06x squared plus 11.82x plus 57.31. And our coefficient of determination is r squared, which is 0.898. Let's give it 3 decimal places. 0.898. And so it's kind of sure. It's pretty close to being sure. It's not 100% sure. We're going to go over to y equals. We're going to type in that equation. 6x squared plus 11.82x plus 57.31. All right. We're going to go over to our table, and we're going to estimate after 7 hours is what it wants to know. 7 hours. 88.11. Okay. Why on earth would it start going down? 88.11 at 7 hours. It's quadratic, we know that, but the more you study, the less you also sleep. You got to get that in there too, right? All right, the last problem for today says, what is the exponential line at best fit for the numbers of members since 2000 that is represented in the table? It's doing exponential. It wants to know exponential line, and then it wants to know the correlation coefficient. Correlation coefficient, and then it wants to know the estimated number after 10 years. Remember, we are talking about members, so we're rounding down. Now, with these numbers, don't do 2000, do 0, 1, 2, 3, 4, right? Always start with the year 0. It says since 2000 in the instructions, so 2000 is year 0. So we'll plug this into stat, edit. We have 0, 1, 2, 3, 4. We need to delete the rest of the information on there. And then we need to change this info. 5, 10, 20, 40, and 80. All right. And we said that it was going to be exponential. So down here toward exponential. And it tells us the exponential function is going to be 5 or y equals 5 times 2 to the power of x, which is great. And then it says our correlation coefficient is 1. What does that mean? It means it's exact, right on the money, 100%. It is certainly positive. So we go over to y equals. We're going to type in that equation, 5 times 2 to the power of x. And then we're going to go to our table and check when it says year 10. Year 10, it's for certain that there will be 5,120 members as to whatever we're talking about. Okay? I hope you understand what's going on. Correlation coefficient is just giving you a good idea of how accurate your information is. Notice the more accurate the information, the less crazy the data, right? Or the less crazy the equation. This one's 100% accurate. Pretty easy equation. This one's less, and the equation really starts getting ugly. This one's a little bit better, and it's not too bad, okay? So correlation coefficient is just there to tell you how accurate your data is. All right. Have a great, wonderful day. I will post another video key. Bye.